All right, so I just wanted to give you some explanation for this problem since I didn't want you to just be copying it, and I wanted to show you some things that are pretty important. So when I first did this problem, I just didn't really think about the masses, and I assumed that this is the way everything would move. Both the masses have to have the same acceleration because they're attached. And if they didn't accelerate at the same rate, the string would either break or they'd get all bunched up. So that's how we know that they have to move at the same rate. These types of problems I think are easiest if you separate the masses and look at the forces acting on them separately. So if we start with mass 1, the forces that we have acting on it, there's the tension in the rope, which has to pull up on it because rope can't push. And then you have the weight, m1g. And notice that I had already decided that that acceleration was downward, and this is something that's kind of important that I wanted you to know about that direction. It doesn't matter if you choose the wrong direction for acceleration because, as you'll see, your answer will come out negative. So if I look at the forces in the y direction for this problem, I'm going to choose up as positive and down is negative. So tension is up, so it's positive. The weight is down, so it's negative. And then on the right-hand side, I have to make that acceleration negative too because it's down. And this is really important because this is a common mistake where students would forget that negative sign. And if you forget that negative sign and you said the acceleration is downward, you'll get the wrong answer. So you can't get the right answer if you forget that sign. So here's one equation that we get. If we do mass 2 over here, so it's sort of tilting. Ugh, that's not a very good drawing. And so for an inclined plane, we do the x and y axis. The x-axis is parallel to the slope of the incline, and then the y-axis is perpendicular to that. And then we have to keep in mind that the gravity acts straight down, and also this angle theta right here that it makes with the negative y-axis is exactly the same as the angle of the incline. And then we also have the normal force. We're going to have the tension in the string, and that's it. Those are the forces we have. So we can actually do forces in the y and the x direction here. In the y direction, which is like up and down like this, there's no motion, so those forces add up to be 0. So we have the normal forces up in the positive y direction, and then a component of the weight, which is the component this right here, which is adjacent to the angle, so we use mg cosine theta right there. We don't really do anything with this, but it's good practice because if you do friction, you'll need to use this expression eventually. In the x direction, I should also add that this is the direction of my acceleration. So tension is in the positive direction. I'm saying up the incline is positive, and the y component of the weight, mgy, is opposite to the angle theta, so we have m2g sine of theta, and that's down the incline, so that's negative, and we said that things were going to accelerate up the incline, and so that's a positive acceleration. So here's this equation. So we work with these two things. We have two equations, two unknowns. We don't know tension, we don't know acceleration. So how you go about this is pretty up to you. I would take this equation and solve it for t, and then I'm going to take this expression and I'm going to substitute it in here. So I get m1g minus m1a minus m2g sine theta equals m2a. I want to get all the a's on one side so I can solve for it. m1g minus m2g sine theta equals m1 plus m2 times a. So my a ends up to be m2g minus m2, I'm sorry, that's m1g, m2g sine theta divided by the total mass. And I showed you on my work that I got minus 3.57 meters per second squared. And that's because I chose the wrong direction. So actually, everything accelerates in this direction with this acceleration of 3.57. So the negative sign tells me I chose the wrong direction, but the number's still right. Once I know that acceleration, I can plug it into either one of my two equations to solve for tension. I can also use that acceleration is v equals v naught plus at to figure out how fast those objects are moving after 2 seconds. And that's it.